Hello, everyone. Let's give everybody a second or two before we start the webinar. Hello, everyone, and welcome to today's webinar, Supercharging SaaS, the Foodics story. My name is Diogo, and I'll be your moderator. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout this session using the Q&A function in the lower right corner of your console. We will answer everyone's questions after the presentation. After today's webinar, you will receive an email with the recording. If you wish to contact us, please email us at team@singlestore.com. So let me introduce our speakers today. We have Mohammed Radwan, he's the head of engineering at Foodics, and also Dominic Ravita, VP of product marketing at SingleStore. Gentlemen, welcome. We're excited to have you here and excited to talk about your SaaS story, your database journey, use case, challenges, and achievements thus far. Dominic, you now have the floor.
Diego, thank you, and Mohammed, welcome, and all of our guests today. Thanks so much for joining. There's so much going on. It seems like it's conference week, all the same week here in May. It's nice that you're with us today. Our session is titled Supercharging SaaS Applications, and I wanted to give a little bit of a prelude or just overview of what we mean by supercharging SaaS applications. And I think everybody will recognize that SaaS applications are ubiquitous now, and it's easy to see why. Like everything in our daily lives is mediated by some kind of SaaS mobile app or API for our work lives and our personal lives. And when it comes down to which app or API or mobile application you use for your personal use or for your business, it often comes down to these real-time digital moments that are for your internal business management might be, things you can't wait on, like the analytics of what's happening in-store sales, for instance, or for your customers who simply won't wait if they're doing a mobile order in their app and there's some sluggishness or they're hailing a cab, etc. So it's no surprise that every business is trying to digitize and provide these kinds of immediate data experiences through SaaS, mobile, and APIs. And this market this year in 2022 is expected to reach $176 billion USD in revenue, growing at roughly 20%. It's expected to be over $208 billion in US dollars next year. So it's really growing fast. But so are the data challenges, because giving a stellar data experience when in your SaaS application is not easy. You've got real-time interactive users here. You've got the demands for data increasing, and the way that many SaaS products are built by product development teams is starting off with a single node database, something like Postgres or MySQL. The skill set's widely available, and it's easy to start that way. But you start to reach bottlenecks, and that's what we mean by supercharging SaaS, is overcoming these bottlenecks in your SaaS and API applications. And so in today's session, we're going to be hearing from Mohammed from Foodics. SingleStore is used in many SaaS applications in many different industries, both large and small, from startups in ad tech, fintech, to large established Fortune 50 companies like Siemens. But today we're going to hear from Mohammed, who's the head of engineering at Foodics, and he's a web developer with 16 years of experience. He's worked in IT and service industries in multiple different kinds of companies and industries. He's a skilled Laravel and PHP developer, familiar with MySQL and Vue.js, and he's the head of engineering at Foodics, as I mentioned. He also likes to fish, as he was telling us in our prep session. But he promises there are no big fish stories in today's talk. It's just straight his experience with SingleStore and the Foodics journey as they've built their application. So with that, I'll hand it to you, Mohammed.
Well, thank you so much for having me and for the intro, Dominic. Well, let me start with telling you about Foodics. Who are we? Foodics is a leading restaurant tech company in the EMENA region. It was founded back in 2014 in Saudi Arabia, and this is where everything's basically started. Now we have customers all over the world with 35 plus markets worldwide. Basically, we help restaurant owners with all the tools that they need to run their businesses and understand their businesses better. Our 360 ecosystem allows them to be able to assess and grow seamlessly. We provide everything that they need, whether it's a payment gateway, cashiers, devices, KDSs, analytics tool, marketplace, and integrations with third parties. The company is growing bigger and bigger every day. Now, thankfully, we have more than 350 employees. All of them are focused on the customer's needs and success. The most recent achievement for Foodics is that we were able to raise $170 million for Series C fund, and this is by far the largest SaaS Series C round in the MENA region. Now, let me, please, Dominic, can we play the video to explain more about Foodics?
Definitely. Let's cue it up here.
Thank you, Dominic. Now, as you can see, one of the things that makes Foodics unique is the analytics and reports part of the system. We generate more than 200 different reports, sorting from the small ones that gives insights, quick insights to the customers, and all the way to the comprehensive and more detailed drill down kind of reports. The variety of reports that we have allows the customer to understand how businesses, how their business is performing, and they are able then to reassess and reevaluate their strategies and be able to grow more efficiently. Now, we have not only these reports, we have matrices that allows the customer to filter, to group by, and to change how the reports looking like vertically or horizontally, so that they can have an overview on how the business is doing, or how one of the branches is doing, how a certain product or a payment method is doing. Let me go through some of our reports to you. Please, Dominic, next slide. So this is one the dashboard mainly, and this is the main screen. This is the home screen. As you can see, these are like the insights, the overview or the high level of how things looks like in this day. If you can see, we have the number of orders, the net sales done till this moment, and these are semi real-time reports. Also, we have the net payments and lots of other numbers that allows the business owner to understand quickly as a grasp when they look at the dashboard, understand very quickly how things look like. Not only that, but we allow the user to start comparing the day-by-day analytics. Like, okay, I've been doing or I've done 504 orders today. How many orders were done today? So instead of them going somewhere else or exploring through the other pages in the system, we allow them to quickly hover on the analytics bar and understand how they've been doing yesterday and the day before, etc. We also do the same for weekly and monthly analytics. If just a click of a button, and they will be able to see everything happen week by week or month by month. We have also detailed analytics about the branches, like how many active orders for the branches, if there is any open tills, any offline cashiers, any occupied tables, how many are they? This is like quickly giving the insight to the customer. If there is something is wrong with the business, they will be able to act as quickly as possible. Next, please. For the inventory as well is very important for any restaurant owners or managers. They will be able to understand if they have any pending transactions, anything that didn't get processed yet, why did they get stuck, and so on, so that they can act accordingly. Next. So this is how the branches details looks like. The number of items in that branch. If there are like low level items, they can see, for example, if we have low number of tomatoes, for example, let's say, they will be able to figure it out, and instantly they can just order more tomatoes, and that's pretty as easy as that. They will be also able to assess what is the top wasted item, and what is the most consumed item, so that they can understand what they are going to need in the future. Next, please. Of course, we are focusing on the third-party customers, which is the customers of our customers, basically. So we have insights for the customers themselves, like how many orders did they do, what kind of products they love, the branches they prefer, and so on. So these are like the overview reports. They are not a very detailed reports. We have lots and lots of other reports. We have a dedicated reporting section for the whole system. But like any other reports, they can drill down. They can look at how the sales are going per branch, per product, and so on. Next, please. Yeah. So where did we start? We, of course, like any tech company, we started with MySQL. It's the most popular because of our ecosystem. Everything has like its pros and cons. We started with MySQL because basically it was compatible with what we had, and it was easy to use. The thing is, with MySQL, it lacked analytics capabilities, so it's more of a transactional database, not for analytics. But it did its purpose for a while, but then we needed to grow and expand, and that's why we chose PostgreSQL. It served the purpose back then. It had managed database service. It was very easy to use. It allowed parallelism and replication of data, and it offered single tenant architecture features. Next, please. So of course, we had some challenges with Postgres. We used a service provider. We had some issues with that service provider. One of them is like scaling up and scaling out. it was very challenging for us because as you grow, you need to always make sure that you serve more customers and you are seamlessly you're able to grow. But if you have any challenges in that area, it will be challenging for the customers as well. So this is one of the challenges that we had. Another one, the instability, and of course this is very important for the customer. If they are not able to understand or look at the reports, understand how their business is performing, and getting lots of errors and won't be able to match the real numbers, this will be problematic for the customers themselves. The integrity of the data is very important, and that's why we had to build our own integrity verification tool to make sure that everything that is missed in that from that service provider is again recalculated and inserted into the database, basically. So we had to come up with our own tool in order for us to overcome this challenge. The rebalancing, and of course the main challenges of scaling up is rebalancing the data. So we hosted, like, we had multiple nodes to host the data, and in order for us to be able to scale up, we had to buy more nodes, and for that we had to rebalance the data so everything is balanced between all nodes. That took like a huge amount of time, a huge amount of effort. So every time we thought about scaling, we started to worry about, okay, are we going to rebalance again? How much time is it going to take? And the amount of effort, of course, is going to take. One of the things that that prevented us from continuing with PostgreSQL is the concurrency. So we had like a very low number of concurrency compared to what we have now, as well as our ecosystem. The whole ecosystem is built on AWS, and all of a sudden that service provider started saying, okay, I'm not going to support AWS anymore. So that was a very big problem for us. Next, please. Yeah, so when we faced these things, we decided, okay, it's time to move on. We need to look for something that is more reliable, that allows us to grow, and we can rely on for the next 5, 10, or 20 years moving forward. And then we started asking ourselves some questions. What do we need? Basically, we need a place so that we can host all of our data in. We have a unified data store, place somewhere. We want it to be fully managed, so we need to worry. We need to focus on our tasks, and we don't need to worry about managing the engine itself or the data. We want something to be very performant because, as you know, we were doing real-time and semi-real-time analytics. We want to be able to scale either up or down without worrying about the time it's going to be consumed or the amount of effort is going to be we're going to take. We need something to be reliable when it comes to real-time data analytics, something that is has a very high availability, almost zero downtime, because the customers or restaurants can explore the system anytime. Basically, they don't. We have like 24/7 restaurants, so we cannot say, okay, we're going to need some time off, or we're going to delay some reports for you. And the most important thing is the concurrency. See, when we grow, the number of customers grows with us. So imagine if you have a very low number of concurrencies, you will be able to serve some customers and some customers not, or maybe delay the whole process for all customers when all of them like request reports all together. For that, we needed something that allows us a seamless reporting selection of reports without worrying about how many customers are going to request these reports. Next, please. So that started to drive us to look for alternatives, drive away from our previous service provider. We looked for multiple service providers until we came up with a very, very interesting article by Jack Ellis. And that article explained everything that we were looking for and above that. So because of we all work in the same ecosystem. We use Laravel and they use Laravel. So we decided to look at the article and understand how things works for them. So we communicated with although we talked with other providers as well, and we started comparing things. And then we engaged with SingleStore and asked them, okay, guys, how do you do it? What do you do exactly? And this is where things started to happen. Next, please. All right. So why did we pick SingleStore? First thing is the ease of use. So the system is not complicated. It uses MySQL syntax, and of course everybody knows it. We're very used to it. So we didn't have to worry about the knowledge. We didn't have to learn about a new technology or anything. We just plug and play. We can do everything. The SingleStore itself is very special because it's not locked on a specific provider. So you can either choose to go with this or that. So you have many options to go with. The performance, because like the sharding and parallelism allows high throughput, and it gives you like very fast responses for queries, complex and even simple queries, as well as of course scaling your workload as needed. Now, the best part about SingleStore, and this is specifically why we chose it, is the customer and technical support. These guys will never stop until you get what you need. So they are very dedicated and very keen to make sure that you get what you need, and that's very special about SingleStore, honestly. With we were confident that we will be able to grow as SingleStore allows. They grow themselves, and we can rely on them so that we can grow our businesses. Next, please. All right, so once we settled and once we agreed on how we were going to do things, we started some POCs, proof of concepts. We wanted to make sure that what we see or what we hear is real, because it was almost impossible to be real. But yeah, we needed to make sure it's real ourselves. So we started pushing the platform to the limits. We literally ingested like millions and millions of records. We executed like very complex queries, and with wide date ranges. It took like some reports, like we had some reports for 5 years, I think. We generated that report, and we simulated reads and writes, like heavy reads and writes, and we simulated like high concurrencies with reads and writes. And everything was at the beginning, of course, we had some obstacles because of how the structure looked like, and we had to change and adapt to that until we eventually we succeeded. Like we boomed in finding the best solution with the best configurations and cluster setup. Next, please. So data migration, we started like after that we started like thank you, Dominic. These like sample of how things look like with these executions, with these stress testing tools SingleStore provided us with. We were able to assess, like we were able to run parallel requests at the same time, and it's very low level. So we knew that there is no like any other things other than the requests themselves are direct. So we pushed it to the limit so that we can see any downtimes or any heavy loads. Nothing happened, and as you can see, all of them went successful. Next, please. So SingleStore provides like various cluster sizes, and this is when we started. We started like with the smallest. They don't just like sell you the thing. Okay, go ahead and buy this. No, they start with you small, and they are flexible so that they get you what you exactly need. They don't get you something more or something less. They get you exactly what you need. So we started with S2, although it was very small cluster. But we started with it, and we started scaling up till we found that S32 is the best decision to take, or best choice to take. So the average query performance was like less than a second, because this is one of our SLAs. We didn't want anything to be executed more than 1 second. So all of these queries, like comparing clusters and workloads, all of these queries got executed below 1 second. We tested every possible partition ratios that we can have. We started with 4:1, 8:1, and all the way to 16:1 partitioning, and that's where also we settled. That was the best performance for us. Next, please. Yeah, so that when we after all of these were like POCs. We didn't actually start working on anything yet. We didn't even decide or agreed that we will go with SingleStore. So we just needed to make sure that everything is fine before we take the next step. After all of these trials and POCs went successful, we started migrating the data. So the data is we have like we've been operating since 2014. You can imagine how much data we have. We're almost at the big data stage now. So in order for us to move the data, we need to study how it's going to happen. SingleStore helped us with lots of tools. They have like lots of tools to ingest the data and to move the data from one provider to another. And they've been like continuously supporting us step by step. Although they have these tools, but due to the complexity that we had in the previous architecture, the database structure, we had to build our in-house migration tool, and that's what helped us moving the data basically from SingleStore, from the other service provider into SingleStore. We've been able to test and reevaluate, and eventually SingleStore gave us the ultimate setup, or the ultimate cluster that we had, or we were going to have in the production environment, so that we can simulate how much time the migration will be completed at. Next, please. Yeah, right. So this is how the architecture looked like before. We had like the transactional database. So it's MySQL, and what happens is that whenever a transaction happens in the transactional database, it gets inserted or updated into and inserted into the reporting database or the reporting reporting analytics database, and that was on top of Postgres. So it's like a direct transaction. But moving forward, we changed that to have some other a more efficient way to ingest the data. Next, please. No, one before it, please, Dominic. Yeah, thank you. So now we had to build something more smarter than just moving or copying the data from the transactional database into the analytics database. We had to come up with a solution that allows us to have more control on what we do, basically. So whenever a transaction happens in the transactional database, It just pings the reporting engine, the reporting service, and then the reporting service would decide whether or not it should start ingesting new data. So it's something, it happens like dynamically, and we have more control over what happens in our database. Next, please. So what was the impact for all of that? Now, first of all, what we are focused on is the customer satisfaction. So you can imagine if you have a customer complaining all the time about the reports, and the reports are the most important part of our system. If they complain all the time about reports, they eventually will get tired and they will churn. So this is something that we were looking forward not to have, and thankfully we were able to improve the performance of our queries and the performance of our reports by more than 60%, and we were able to some reports were gets executed within the range of 200 milliseconds. Now they get executed within less than 60 milliseconds, and that's, of course, this is a very, very, very great number. Now we are able to scale without worrying, knowing that we will have more concurrent users, because we get more customers every day, and of course the offer that we had from SingleStore, it was a great offer, and for that we have 10x the power and 100x the performance and cost efficiencies. Next, please. Okay. So yeah, that's, I think that's,
yes.
sorry.
Terrific. Let us get to our next part here. Thanks for that explanation. It's really interesting journey and set of challenges. Mohammed, thanks for sharing that story. Mohammed's going to stay on for our Q&A, which directly follows this in a couple of minutes. So, you know, we talked about supercharging your SaaS applications, and why would you choose SingleStore database for your SaaS application? Generally, we see that, as I mentioned in the beginning, it's typically you're having some sort of data bottleneck, and I think Mohammed's story and journey and Foodics journey is one great example of that. You're trying to achieve a particular outcome in your product. Perhaps it's a data experience for your users, your end users, or it can be something internally that you're trying to track, and you have these analytics with SLAs, or these can't wait or won't wait analytics and data and computations that need to be performed for an operational moment, or for some sort of business moment that you're trying to capitalize on. And with switching costs so easy among different kinds of digital products, SaaS, mobile apps, APIs, this is really where the playing field is. So what SingleStore helps you to do in your SaaS application to supercharge it, as we say, is solve these three problems for you. First, to give you this performance boost for the kinds of queries that you might have KPIs that are continuously being calculated, or you've got interactive queries on fast changing data. Secondly, you're trying to do this while simplifying your cloud data estate. The approach we've seen over the past decade or so to meet the challenges of increasing data intensity, and what that is when data becomes the bottleneck that's holding your application or your experience back. We're seeing that the response to that is to add more specialty databases or special purpose types of databases, like you see here in the middle column. And the complexity that this creates is that now even if you're running this in a cloud environment, you have to manage these multiple different systems. Your team has to have the skill sets across these. You're managing the integration, the pipelines among them. And often you know, like in the case of Elastic, say you still have operations in each system to re-index the data that you replicate over to a system like that. And so it can still be behind and the experience may still lag, but now you've got a more complex data system supporting your single application. And so SingleStore simplifies this, and by simplifying that, it helps to reduce the cost. And Mohammed spoke to this as well in terms of the parallelism that they found with SingleStore. We use really, especially with the flexible parallelism that was released recently, we're using every thread of every core that you're paying for in your cloud environments for those queries. And you don't get as full utilization of the compute that you're paying for with cloud with other databases. That's just one example. There's lots of efficiencies that we bring to these kinds of operations on your data, which brings us to the third point, is that the whole SingleStore database is built top to bottom to optimize for real-time data, for the whole real-time data lifecycle. At the ingestion phase, we ingest data from distributed sources like Kafka, Spark, object storage, etc., in parallel into our distributed database. So you get the full throughput of as many. Typically, you line up the number of partitions and nodes from your distributed data source, like Kafka partitions, to the count of nodes or partitions in SingleStore, and you get massive ingest. That's one real-time optimization. Once the data lands in SingleStore, the way it's stored in our unique universal storage, which is this hybrid that we've unified row stores and column stores to create a transparent, simple interface or storage type called universal storage. So there's a lot more to say about the whole system, how it's optimized top to bottom for these kinds of use cases for real-time operational analytics. And this is what helps to meet the challenges of modern SaaS applications delivering these data experiences. And when it comes down to what are the key things you're looking for in the workloads, it's similar to the Foodics example that Mohammed just described, is that you're dealing with one or more challenges in these types of areas. And we look at these characteristics, these are sort of three common ones we see as dimensions of your data intensity challenge, of where you're going to find the bottleneck. Often it's in the combination of these things, getting the data in fast enough, how fast can you query that data, the low latency query aspect, and the third is how fast can you serve that data to your concurrent users of your UI or your API interface, etc. The way we achieve this is, as I said, by unifying transactional operational workloads with analytical workloads. By the reason we bring these two together is so that we can reduce data movement. We do this with a single table type called universal storage, as I mentioned. And by simplifying the data system into one unified system, we can operate on blazing fast sets of data, really large sets, give consistent response times, query times that are consistent and low latency, without a lot of variability you would see in cloud data warehouses and things like that for analytics. And we do that because our product architecture is designed in such a way to give you the consistency for low latency queries. But when you have large data sets that maybe don't have all the data in the working set that's active or hot, we do have separation of storage and compute. So that helps you with your unit cost for storage, so you can get into petabytes of data in your database and it's still very cost effective, while your hot data is in our universal storage, such that you can get really fast response times on that. We also serve this for a wide set of different data types. Again, rather than having to pick a database per workload, SingleStore is multi-model, meaning that it has a relational foundation. It is a distributed relational database. But it also supports these other models you see depicted here as first-class citizens. So we have the data types to support each of these data models as well as the built-in functions, and we're getting better and better at each of these with every release. So with that, I think it's probably a good time to open up the floor to questions, Diogo.
Thank you, Dominic. Thank you, Mohammed. It was really interesting. So here's the first question. Did you also perform a backup data from SQL, and how you perform it?
Well, yeah, we had backups, but it wasn't. It was like based on months, because basically we used MySQL back in the days. It's the first database engine that we worked with.
Awesome. Here's the next question. How was the migration done?
The migration was done. We like had a big server because we were short in time and we wanted the data to be moved fast. We were able to replicate the main database that we're going to copy from, have its own cluster and replicate it so that it won't affect the production database. And basically, we were copying everything. Of course, we had a single tenant architecture. We wanted to move that from a single tenant into more multi-tenant architecture. In order for us to do that, we need to have some operations happening in the middle. It's not just like copying and pasting things. So we had to come up with a big server in the middle, and then we started that process.
Awesome. Next question here is, are the databases geographically distributed as well?
No, it's just that's a good question, but the focus is not the geographical location now. It's more of everything is placed in a single placement or a single database warehouse.
Next question is, can we also do a graph DB?
I'll take that one. Because we are a relational database, you can model graph. We have done that for a few customers. Depends on the kind of graph use case you have. If you were to model it as an adjacency list, and you build that hierarchy or traversal, you build the graph essentially with an adjacency list, and you give the reference. That's the classic way to sort of model it, and then you can traverse the path that way. But we don't have specific support for like Gremlin or these other sorts of graph query languages. We're straight SQL. If you have a use case for graph with SingleStore, we'd love to hear it. In many cases, you can model a good enough graph use case in relational. So hit us up in the forum at singlestore.com/forum. Happy to take a look. But that said, we are not we don't have dedicated like Cypher, Gremlin kind of graph API support.
Another question for Dominic. Does SingleStore work with Microsoft technologies such as SQL database?
If I understand the question correctly, supporting Microsoft SQL databases. So if your question is about a migration, like how could we migrate data from Microsoft SQL Server? Yes, we can do that. We can do that through our CDC and ETL partners as well. Change Data Capture, CDC. If it's accessing SingleStore from Microsoft technologies like the .NET programming language and ODBC drivers, yes, you can connect to SingleStore from literally hundreds of languages because we have a MySQL wire protocol compliance interface. So literally any MySQL or MariaDB driver in your language of choice, you can use that to connect to SingleStore, including Microsoft technologies.
Awesome. Another question from Mohammed. How long has Foodics been using SingleStore?
We're almost at a year now, I believe, or maybe a little bit less than a year.
Awesome. Another question here. Is there any proprietary connector for Fivetran with SingleStore?
Fivetran with SingleStore. That's a good question. Let us follow up with that.
Okay.
I would say that.
And what about? Sorry.
Yeah, we'll look that up. But if there, I would expect Fivetran would have a MySQL or MariaDB client connector. As I said, because we're MySQL and MariaDB wire protocol compliant, you could use either of those two connectors. But we'll look to see if we have a particular SingleStore branded connector from Fivetran.
One other question here is, how can we compare the performance of SingleStore with NoSQL databases like MongoDB or Cassandra?
Well, it depends on what workload you're modeling. So we have some tools that help you with this. If you go to our GitHub org under it's /memsql, which is our previous name, so github.com/memsql, you'll find various performance testing toolkits. Our other GitHub repo, by the way, is SingleStore-labs, and you'll find a lot of other useful kits there. Both MongoDB and Cassandra are OLTP or operational transactional focused databases. So the kinds of workloads you would expect to compare SingleStore with would be those sorts of benchmarks. I would say that the case to where to use SingleStore in those scenarios is where you've got transactions or OLTP things you might be doing with Cassandra or Mongo, but you also find the need to do some analytical queries in addition to that. That combination is really where it's worth you to take a look at SingleStore, because those other two, Cassandra and Mongo, just simply can't do any sort of analytical type queries. And the ways that they provide to try to do that are sort of, out of band, out of process. Sometimes it's a middleware approach, like with something external. That becomes a complexity that your application has to manage. If it's pure OLTP only, probably SingleStore is not the best choice. But if it's OLTP with some analytics, that's when you should take a look. And that's when I'd say it's worth comparing Mongo and Cassandra to SingleStore.
Thank you. Another question to Mohammed here. It's a long one, so let me know if I need to go back to it. You have so it means that you have business data in transactional database and projections in analytical database. When analytical database gets a signal on a new data existence, does it query all of the data from transactional one or aggregate it only on a fly? Does analytical DB drop performance of transactional DB?
It's a good question on the long one. Yeah, that's a good question. So okay, let me answer one at a time. So one question at a time. So yeah, we have two sets of databases: transitional database and analytical database. The transitional database signals to the reporting, and then we aggregate the data into, or we ingest the data into the reporting database. Of course, this happens smartly, so we control how things gets inserted. So we just not to pile up or overwhelm the processor. The performance, regarding the performance, again, as we said, we have a kind of smart or controllable ingestion way. So the performance itself, it doesn't drop. Because we are handling we rely on or we study the data load before we start inserting the data.
Another question, I think, for Dominic here: is SingleStore available in Microsoft Azure?
Yes, absolutely. We're available in the Azure Marketplace. We're available as a service from SingleStore.com. If you go to SingleStore.com/free, you'll see how to start up your free trial on SingleStore DB, and you can just choose Azure and choose your region. So we're also available as a service on AWS and also Google Cloud Platform. We're also available to self-manage. So if you prefer to manage it yourself in your data center or cloud environment, then you can use SingleStore that way, as well as operate it on Kubernetes through our Kubernetes operator. These days, most folks start with not managing any infrastructure. So yeah, you can come straight to SingleStore.com and start your SingleStore cluster on Azure that way.
One last question here, Dominic. Can I connect to my SingleStore DB as a data source from any ETL or analytical tools, example Python or SAS?
Yes. Those languages like Python, for instance, has a MySQL and MariaDB driver. So I just tried this the other day just to see how many lines of code that I could do this, and it's just literally just boilerplate Python code with it's like less than 10 lines of code, the whole Python thing to connect to SingleStore. So it's like you just import the MySQL driver from Python. So do your pip install and there you go. Say with SAS, SAS software, I assume is what you mean there. Same goes for that. They have a MySQL connector, so you can connect for that. If you look in the SAS documentation for SAS Viya, the latest version, you'll see the connector there under MySQL, and there's a statement. You have to change your lib name in your connect string to specify a SingleStore. That said, if there's interest in SAS, we have an extensive partnership with SAS, and we're powering the new modern data tier under SAS Viya, as we previously announced, and that's coming soon. So I'd say stay tuned to this space for more information about SingleStore with SAS Viya.
That's all the questions we had for now, Dominic. So I want to thank Dominic and Mohammed for a wonderful panel today. Thank you to the audience for attending the webinar today. Please check out our solution brief on Supercharging SaaS application. We've added it to our handout tab in the GoToWebinar console, or you can head to singlestore.com/resources to check it out. We will send everyone a follow-up email with today's recording and a link to our managed service free trial. We are offering each user $500 in free credits, so you can start a full workload today. I'll be pasting the link here on the chat so you can go directly to it and start a free trial. Thank you everyone for joining, and have a great rest of the day.
Thanks, Diogo.
Thank you all.
Thank you.
Bye, Dominic and everybody.